Hello everyone, welcome to AI with Sai, your go-to channel for learning and mastering the art of problem solving. So this is the new series where we'll be tackling 20 fundamental patterns on LeetCode. So if you ask why LeetCode patterns, well, there is an answer for that. Whether you want to become an AI engineer or data engineer, one thing is very important. You need to be master at problem solving. Companies look for engineers who can think critically and solve complex problems efficiently. So that's why this series is very important. So in this series, we are going to explore 20 essential patterns that cover a wide range of problems on LeetCode. So by mastering these patterns, you will have the tools and techniques to solve virtually any problem you encounter on the platform. So each topic will break down a specific pattern, providing you with clear explanations, coding walkthroughs, and interesting stories to make learning fun and easy way. So, whether you are preparing for coding interviews, looking to sharpen your problem solving skills, or aiming to become a proficient AI or data or ML engineer, this series is for you. So, let's dive into our first pattern and start our journey to mastering LeetCode together. Imagine you are a space explorer on a mission to find a hidden treasure on different planets. So each planet is marked with a number and they are all lined up in order from smallest to the biggest one. Now, your goal is to find the treasure hidden on one of these planets. So for that, let's use binary search to find it quickly. Let's say our planets have these numbers on them. And we are looking for the planet with the number 9. We need to find it without checking every single planet. First, we look at the middle planet. But wait, how do we find the middle planet? So generally in binary search, we use this formula to find the middle index. Here we start with the leftmost index as 0 and the rightmost index as 5. So the middle index is calculated as 0 plus 5 divided by 2, which gives us 2. The middle planet in our array is at index 2, which is the planet with the number 3. Now, is this the planet with the hidden treasure? Absolutely no. 3 is smaller than 9. But this tells us something very important. Since our planets are in order, we know that all the numbers smaller than 3 are on the left side and all the numbers bigger than 3 are on the right. So we can ignore all the planets to the left of the 3. Now we focus on the remaining planets on the right side. We need to find the middle of this new range. So middle index is calculated as 3 plus 5 divided by 2, which gives us 4. The new middle planet is at index 4, which is the planet with the number 9. We only had to check 2 planets to find it. So that's much faster than checking every single one. So based on the concept that we have learned, we are going to solve a LeetCode question and the problem number is 704, which is a binary search. Now let's understand the question. Given an array integers nums, which is sorted in ascending order, and also an integer target. Now we have to write a function to search target in nums array. If target is exists, then we have to return its index. Otherwise, we have to return -1. And also another condition, you must write an algorithm with O of log n runtime complexity. So if you observe this example, we have already discussed this example in our previous story. So we have to find this target variable inside this nums array. And also we have to return its index, which is 4 here. If you observe this example too, the target variable is not present inside this array. So that's why they have written -1. Now here they have already given the function search and inside that function they have given two main parameters, nums and target. Nums is a list of sorted integers and a target is an integer that we have to find inside this array. Now let's start by initializing two pointers called left and then right. Here we initialize two pointers, one is left and another is right. Left is set to the beginning of the list at index 0. Right is set to the end of the list. Here we start a while loop that continues as long as left is less than or equal to the right. Now inside this while loop, we have to calculate the middle index. So give mid equal to left plus right divided by 2. This gives us the index of the middle element in the current search range. Now we have to check whether the mid element is a target element or not. So for that I'm writing a if condition. If nums of mid is equal to target, then we have to return its index, which is nothing but return mid. Otherwise we have to use if nums of mid index is less than the target. So if the middle element is less than the target, it means our target must be in the right half of the list. So we have to adjust the left pointer to the mid plus 1, which means we have to move the position of the left index right to the mid index. It is effectively ignoring the left half of the list. If the middle element is greater than the target, it means our target is in the left half of the list. So we have to adjust it by reducing the middle index to the -1. So here we are ignoring the right half of the list. If we exit the while loop without finding the target, it means the target is not in the list. So in this case, we return -1. -1. So it means the target is not present in the list. If you run this program, you can see all the test cases are passed. Now submit it. I'll give an example to understand what we are doing here. So if we have 1000 elements, the first comparison reduces it to 500 elements, and the next comparison will go to 250 elements and then 125 and so on. So you can see how quickly the number of possibilities shrinks. So that's it for this video. But why don't you subscribe? It's free.